Hello and welcome to this session, LO2. Understand the main functions and features of operating systems. Today, we will explore how operating systems manage complex tasks seamlessly, focusing on their key roles in process management, hardware control, and file management. Operating systems perform four core functions: process management controls, program execution, hardware management handles device drivers and interrupts, file management organizes data storage and permissions. User interface management provides interaction through GUI, CLI, or MUI. A program becomes a process when executed. Each process has its own memory and CPU state. Threads within processes share memory but have separate stacks. Multithreading allows concurrent task handling. Context switching enables multitasking on single-core CPUs. First come first served schedules processes by arrival. Round robin gives each process a time slice. Priority scheduling runs high-priority processes first. Each method has its pros and cons. These algorithms affect system responsiveness and fairness. Each process has a virtual address space. Memory regions include text, data, heap, and stack. The OS maps virtual addresses to physical RAM. Heap grows upward, stack grows downward. Virtual memory uses paging for efficient management. Inter-process communication allows data exchange between processes. Methods include pipes, sockets, and shared memory. Hardware management uses interrupts and device drivers. Interrupts signal the CPU for attention. Drivers translate OS requests for hardware. The OS allocates CPU, memory, and I/O resources. CPU scheduling decides process execution order. Memory management uses virtual memory and paging. I/O requests are serialized for efficiency. Deadlock prevention ensures smooth resource allocation. Operating systems support multiple users simultaneously. User sessions are isolated by UID and GID. Process ownership prevents unauthorized access. File permissions control read, write, and execute rights. Interfaces like GUI and CLI enable user interaction. Copying a file involves several system calls. The OS checks permissions before opening files. Data is read into a buffer and written to the destination. Page cache operations optimize disk access. Metadata updates ensure file consistency. This is the title for this scene. This is bullet point 1, this is bullet point 2, this is bullet point 3, this is bullet point 4. Time sharing allows multiple processes to share CPU time. The OS rapidly switches between processes. Context switching saves and restores process states. Timer interrupts enable preemption. This creates an illusion of simultaneous execution. Time sharing ensures fairness and responsiveness. CPU-bound and I/O-bound processes are balanced. Quantum size affects context switch overhead. Smaller quanta increase responsiveness but add overhead. Multi-core CPUs allow true parallel execution. Operating systems manage processes, hardware, and files. Scheduling algorithms affect performance. Memory management uses virtual memory and paging. IPC methods enable process communication. User interfaces support interaction and multi-user environments. Identify and explain the four main OS functions. Describe CPU scheduling and memory allocation. Explain multi-user support and interface types. Merit requires understanding file copy processes. Distinction involves evaluating time-sharing trade-offs. Simulate scheduling algorithms with Gantt charts. Trace file copy operations and permissions. Analyze context switch timelines. Evaluate time sharing on single-core CPUs. Discuss how additional cores alter CPU allocation dynamics. Explore textbooks like Tannenbaum's Modern Operating Systems, Geeks for Geeks offers scheduling examples. Nesso Academy provides structured OS lectures. Brian Will covers OS internals in detail. Access UK Versity resources for comprehensive learning. Explore further to deepen your knowledge of OS intricacies. Have questions? Send a WhatsApp to 074-843-61688 and our team will be delighted to assist. Thanks for your attention, and see you next time.